So, we had derived and discussed equations in relativistic dynamics, where particles collide, split, scatter from each other, forces are applied, linear momentum, energy, all these things, relations between them, we did that. So, today I will be doing some problems, so that those concepts get crystallized better. So, our first problem is a particle has kinetic energy which is 1/4 of its total energy. A particle has kinetic energy which is 1/4 of its total energy. Find the speed of the particle. So, a particle has kinetic energy which is 1/4 of its total energy. Now, what is kinetic energy and what is total energy? Kinetic energy we had defined K, that is m naught c square divided by square root of 1 minus v square by c square and minus m naught c square. How do I remember that? Kinetic energy is total energy minus the rest mass energy. So, this is the rest mass energy and this is total energy. Total energy is m naught c square divided by this. So, total energy is m naught c square divided by square root 1 minus v square by c square, that is total energy. You can write this as m naught c square gamma, and you can write this as if you take this m naught c square common. So, this is m naught c square, if you take common it is gamma and then minus 1. So, divide, this is 1/4 of the total energy. So, this divided by this should be 1/4, and hence 1/4 should be equal to m naught c square gamma minus 1 and divided by m naught c square and gamma. So, it tells me that this cancels out, gamma minus 1 divided by gamma, that is 1 minus 1 by gamma. So, you can see, you can take this 1/4 on that side, 1 by gamma on this side. 1 by gamma is equal to 1 minus 1/4, that is 3/4, and 1 by gamma, you know what 1 by gamma is? It is the square root of 1 minus v square by c square, because gamma is 1 by square root 1 minus v square by c square. So, this is 1 by gamma, this is equal to 3/4. So, square 1 minus v square by c square is equal to 9 by 16. So, v square by c square is 1 minus 9 by 16, that is 7 by 16. So, v by c is square root of 7 divided by 4, and that will be around 0.66 or so, and therefore, v is 0.66 into c, and that is 0.66 into 3 and into 10 power 8 meter per second, which will be almost 2 into 10 power 8 meter per second. So, 67% or 66% of the speed of light, then the kinetic energy will account for 1/4 of the total energy. Let us take another question. This I discussed in the previous lecture also. Find the speed of an electron having kinetic energy say 100 eV. Find the speed of an electron having kinetic energy (100 eV). So, what is the speed? And this is electron, remember. So, the kinetic energy is 100 eV and the rest mass energy is 511 kilo electron volts. So, this 100 eV is much smaller than this 0.1 keV and this is 500 keV. So, 1 part in 5000 or so, and therefore, one can use non-relativistic equations unless you are doing some very sophisticated experiment. So, I can use this half mv square, k is half mv square and that is 100 eV. We have to find this mass, this speed. So, we can write v square is equal to 200 eV divided by, right, v square is 2 into this divided by mass. Mass I can write 511 keV per c square like this, because mc square is 511 keV, that is the rest mass energy. So, the rest mass is this 511 keV divided by c square, which you can write in this fashion. So, this c square can go here and from here I can put it here. So, it is v square divided by c square, which is equal to 200 eV and then you have 511 and into 10 power 3 eV. So, EV cancel out and you have this equation. This is now you can solve it, 200 by 511 into 10 power 3. So, you can simplify this 100, you can cancel if you so wish. It is 2 divided by 5110 and from here you get V by C and V by C will be square root of this 2 by 5110 and you can work out how much it is. So, and that is 0.01978 etc. all right. So, V is 3 into 10 power 8 and then multiplied by this quantity 0.01978. So, meter per second, which is equal to, so I multiplied by 3 into 3 and that is 0.05935 etc. We will stop at 0.059. So, it is 0.059 into 10 power 8, which is say 5.9 times 10 power 6 meter per second. So, that is the speed if it is 100 eV. So, our next question is very similar to the previous one. Again we have to find the speed of the electron and this time the kinetic energy given is 1 mega electron volt. So, the question is find the speed of an electron having kinetic energy (1 MeV). So now the kinetic energy is not small compared to rest mass energy. In fact, it is more than rest mass energy. The kinetic energy K is 1 MeV, that is 1000 keV, whereas the rest mass energy m naught c square is 511 keV. So kinetic energy expression, relativistic expression must be used here, and that expression is m naught c square and then gamma minus 1, and this is m naught c square here. So you have 1000 keV is equal to 511 keV and then into gamma minus 1. So gamma minus 1 is equal to 1000 and divided by 511. Gamma minus 1 is equal to 1000 divided by 511. So gamma is equal to 1 plus this. So 1511 divided by 511. That is gamma. And then you can write 1 by gamma, which is square root of 1 minus v square by c square, and that is equal to 511 divided by 1511. So square to get 1 minus v square by c square, that is 511 by 1511 square. So if I do that on my calculator, what do I get? It is 511 divided by 1511 and then square of this, that is 0.11437 or so. So let us write 0.1144. So that is 1 minus v square by c square, and therefore v square by c square, which is 1 minus this quantity. So it will be 0.8 here, 8 here, 5 here and 6 here. So you can write what is v by c, square root of this. So let me do that. Let me do that also. Square root of 0.8856, and that is like 0.94. This is like 0.941, 0.94. So V is equal to 0.94 and into C. C is 3 into 10 power 8 meter per second. So multiply by 3 also 2.82 into 10 power 8 meter per second. The next question is two particles of same rest mass m naught move towards each other, move towards each other with equal speed v, with equal speed v. They make perfectly inelastic collision. They make perfectly inelastic, perfectly inelastic collision and make one composite particle and make one composite particle. Find the rest mass of this particle. Find the rest mass of this particle. So, what is the situation? Two particles of same rest mass m naught move towards each other with equal speed v naught. So, you have a particle here m naught, rest mass m naught, and another particle same rest mass, and they are moving with same speed v. This is v and this is v. And then they make collision, perfectly inelastic collision, and then the two combine to form one single composite particle. So, this is before the collision, this is the situation before the collision, and after the collision they combine and make one single particle, and you have to get the rest mass of that particle. That is the question. Now, the first thing is that linear momentum is 0 here. Linear momentum is m naught into v into gamma. So, since m naught is same, v is same, therefore, gamma is same, and the linear momentum has same magnitude, and since they are in opposite in direction, so the total linear momentum is 0. So, after the collision also the total linear momentum should be 0, and now you have only one particle, and therefore, its speed should be 0, it must be at rest. So, here it is at rest. So, that comes from the linear momentum conservation. And now, let us make energy conservation. Which energy? Total energy. You have energy and momentum as one 4 vector. Energy E naught by C and then Px, Py, Pz, that is a 4 vector. They are separately conserved if no forces, no external forces act on the system. So, total energy should be conserved, and here total energy you can write total energy before the collision. You have same total energy for this and for this. So, it is E is 2 times and then m naught c square by square root 1 minus v square by c square gamma. So, 2 times m naught c square into gamma, that is the total energy of the two particles before the collision. And after the collision, what happens? After the collision, you have a particle of rest mass capital M naught, which is at rest. Hence, the total energy is same as the rest mass energy. So, after the collision, the total energy is just rest mass energy m naught c square. And since total energy remains conserved, even if it is in elastic collision, in non-relativistic mechanics, when we say inelastic, perfectly inelastic, we mean that the kinetic energy is lost. Here we say that kinetic energy is not lost, total energy remains constant. Kinetic energy is lost, but then this rest mass energy should appear. So, let us see. So, this total energy should be conserved. So, 2 times m naught c square and square root 1 minus v square by c square, that is capital M naught c square. So, capital M naught is 2 times M naught divided by square root 1 minus v square by c square. So, that is the rest mass, and you see that this rest mass is greater than the original rest mass. Before the collision, the rest mass was 2 m naught. After the collision, it is 2 m naught divided by this quantity. So, it is more. So, rest mass energy has increased. So, whatever kinetic energy was here, which was lost because it comes to rest, that kinetic energy is converted into the rest mass, and rest mass of this particle is more than the rest mass of combined rest mass of these two particles.